All right, so today we're going to talk about asymptotes. But before we begin to talk about asymptotes, I just want to review some special linear equations. And the two special linear equations we're going to talk about are horizontal lines and vertical lines. And just to review this, because we're going to talk about asymptotes and they're going to play on the horizontal and vertical lines. Okay, so for horizontal lines, they're written in the form y equal to c, right? So in the equation for a horizontal line, there is no x coordinate or x variable. So for example, let's just say we had, that's a 1, a 2, and a 3. So let's just say if this was our line, the equation for this line would be y equal to 2. All right. For vertical lines, they're in the form x equal to c. All right, so here again, for a vertical line, there is no y coordinate or y variable in the vertical line. Okay, so if we have a line as such, the equation for the line is going to be x equal to 2. All right, so just reviewing special types of special types of linear equations. Okay, next we're going to talk about an asymptote. Okay, and we're going to talk about 3 types of asymptotes: vertical asymptotes, horizontal asymptote, and slant asymptotes. Okay, so an asymptote is a line. Okay, and this is just in general terms. It's a line that your graph touches. Well, it's a line that the graph never touches. So we'll take a look at some examples. So here is an example of a horizontal asymptote. Okay. And horizontal asymptotes are basically imaginary lines, imaginary vertical lines, imaginary horizontal lines. And we're also going to look at what are called oblique asymptotes, which are sometimes called slant asymptotes, and I believe this book uses slant asymptotes. Right, so here is an example. Let's just say we have this curve that looks like this. And my line isn't exactly as straight as today. Okay, so if we look at this particular line, right, this line would have what's called an horizontal asymptote. So I'm going to kind of draw this little dashed line. So notice that our graph, it gets closer and closer and closer to this horizontal line, but never actually touches the line. Okay, so that would be the definition of a asymptote. And since this line is horizontal, this is a horizontal asymptote. All right, so the goal is to identify the asymptotes, and then we'll also be able to pull out the equations that produce these asymptotes. Okay. Next, we're going to look at a vertical asymptote. All right, and for a vertical asymptote, and now these don't have any equations to them, but we're going to take a look at some equations in just a second. Okay, so we take a look at this particular graph. Notice that there is a horizontal line, a vertical line that the graph gets closer and closer and closer to, but it never actually touches. Okay. And then we have what's called a slant asymptote. Okay. Or an oblique asymptote. And a slant asymptote would be a slanted line. All right, so here again, this is actually an imaginary line. It's not actually a part of your graph. And we would have our graph get close and close to the line, but never actually touch the line. Right, so we have the three types of asymptotes, and our objective is to identify these asymptotes and also write out the equation. All right, so let's take a look at some problems. Okay, well, I guess before we actually do that, okay, where am I? Okay, if I go back to our home page in the course, I'm going to go into lecture notes. I'm going to scroll down to chapter 4, and where it says 4.2, this asymptote cheat sheet, I'm going to bring up this asymptote cheat sheet. Okay, now on the asymptote cheat sheet, it shows you how to find the different asymptotes. So if we look at the very first set of items that we're asked to find the vertical asymptote. So notice in order to find the vertical asymptote, so here again, this would be a vertical line, right, that our graph would approach but never actually touch. We would completely factor the numerator and the denominator if possible. Then we would set the denominator equal to 0 and solve. The resulting equation should be in the form of a vertical asymptote x equal to some number. Okay, so if you're asked to find the vertical asymptote, you should completely factor your numerator and your denominator, if possible. Okay, you don't always have to factor them if they're in simplest form. Then you basically set the denominator equal to 0 and you solve. To find the horizontal asymptote, so again, that's a horizontal line that your graph approaches but never touches. You would divide each term by the variable factor of greatest degree. So what that means is, let's say you're looking at an equation and the largest power on x is x to the third power. you would simply divide every term by x to the third power. Okay, and we're going to take a look at an example. Then it says that the equation of the horizontal asymptote should be in the form y equal to a. Now, when you're finding the horizontal asymptote, okay, unlike the vertical asymptote, notice that the set of instructions, we have checkpoints and then we also have bullet points. The checkpoints are there just to see if a horizontal asymptote exists. And then if the horizontal asymptote exists, we would use the bullet points to actually find the horizontal asymptote. Right? So let's check the bullet points. Let's look at the checkpoints. That first checkpoint says if the degree of the numerator is smaller than the degree of the denominator, then the horizontal asymptote is automatically y equals to 0. Okay. So if the numerator is a smaller degree than the denominator, then the horizontal asymptote is y is equal to 0. Okay, and then there's no need to follow the bullet points. The second checkpoint says if the degree of the top is bigger than the degree of the bottom, then no horizontal asymptote exists. Now, one thing I can tell you is that you can't have a horizontal asymptote and an oblique asymptote at the same time. So if you have a horizontal asymptote, you can't have a slant asymptote. And if you have a slant asymptote, then you cannot have a horizontal asymptote. All right, so let's take a look at the horizontal or the slant asymptote. So the first thing I'm going to do here is I'm going to look at the checkpoints, okay, because you want to check to see if a slant asymptote exists. It says if the degree of the numerator is 1 degree greater than the degree of the denominator, then an oblique asymptote exists. Right? So the degree of the top has to be exactly 1 degree greater than the denominator, and then you can find the horizontal, and then you can find the slant asymptote. So now in order to find the slant asymptote, we'll take a look at the bullet point. It says to find the oblique asymptote, we're going to divide the numerator by the denominator. And then we're going to disregard any remainder. And this would give us the equation for the slant asymptote. So as we are finding these asymptotes, we're going to keep this cheat sheet handy. So keep in mind, this cheat sheet can be used for the quiz, it can be used for the test, also for the final exam. All right, so we're going to take a look at some problems. Now, in the homework itself, I believe there's only one problem that actually gives you a graph. And from the graph, you're asked to pull out the asymptote. Okay, but the rest of the problems, they actually give us functions. All right. So I believe this is similar to number 1. We're given that f of x is equal to 3x minus 4 divided by x plus 5. Okay, and the first thing we're going to do is find the X intercept. All right, so how do we find the X intercept? So keep in mind that the X intercept is the same thing as a 0. It's the same thing as the solution to the equation. It's also the root. All right, so in order to find the X intercept, we're going to let y equal to 0 and solve for x. So we're basically going to take our equation. In this case, we're going to take this rational equation, set it equal to 0, and we're going to solve. All right, so I just took that equation, set it equal to 0. Now, the first thing we want to do here is we want to get rid of the fraction. So in order to get rid of the fraction, we're going to multiply both sides by the denominator. So here we're going to multiply both sides by x plus 5. So I'm going to multiply the left-hand side by x plus 5. And I'm going to multiply the right-hand side by x plus 5. All right, so we multiply both sides by the least common denominator. Okay, and the least common denominator was x plus 5. So on the left-hand side, the x plus 5s are going to cancel. So we're left with 3x minus 4. On the right-hand side, anything times 0 is 0. So we have 3x minus 4 equals to 0. So we're going to solve it for x. So we're going to add 4 to both sides. Next, we're going to divide by 3. So we have x is equal to 4/3. Right. So our x-intercept is 4/3. But if you have to write that as an ordered pair, we can write it as 4/3, 0. Sometimes it just wants the x-intercept as a number, right, which would be 4/3. And other times they want us to write out the x-intercept as an ordered pair. All right, for B, we're going to find the y-intercept. And in order to find the y-intercept, we're going to let x equal to 0 and solve for y. Right, so we're going to take our equation, and wherever we see a 0, wherever we see an x, we're going to substitute x for 0. So we have f of x is equal to 3 times x. But we're going to substitute x for 0 minus 4 divided by x, which again we're going to substitute for 0 plus 5. So we have f of x is equal to -4/5. So just remember, in function notation, we let y equal to f of x. So I'm going to write this as y equals to -4/5, right, which is the y-intercept. Or if you're asked to write it out as an ordered pair, we would have the ordered pair point 0, -4/5. Now we're asked to find the asymptotes. And so here's where that cheat sheet is going to come in to play. So now we're going to find the horizontal asymptote. So I'm just going to rewrite the function f of x is equal to 3x minus 4 divided by x plus 5. Okay, so if I go back to the cheat sheet, right, the first thing I'm going to do is I'm going to look at the checkpoints. The first checkpoint says if the degree of the top is smaller than the degree of the bottom, then the horizontal asymptote is y equals to 0. So as I look at this equation, the degree of the numerator is 1 and the degree of the denominator is 1. So both of the degrees are the same, right? So the first checkpoint does not apply. The second checkpoint says if the degree of the top is bigger than the degree of the bottom, then no horizontal asymptote exists. Okay, so both of the degrees are the same. So we're going to proceed with the bullet points. It says to divide each term by the variable factor of greatest degree. Right? So what does that mean? So now as I look at my equation, right, 3x minus 4 divided by x plus 5, notice that the variable is x, and the largest power for x is x to the first. So I'm going to divide everything by x. All right, so I'm going to bring down f of x. I'm going to divide 3x by x. I'm going to divide 4 by x. In the denominator, I'm going to divide x by x and 5 by x. So now here's what happens. When we simplify, if whatever we're simplifying does not simplify to a nice number, then we're gonna put in a 0. So here's what I mean. So 3x divided by x, right? Those x's are gonna cancel, and I'm left with 3. Minus 4 over x. Well, 4 over x doesn't reduce down to a nice number, so that is going to tend towards 0. Divided by x over x, which reduces nicely to 1, plus 5 over x. That doesn't reduce down to anything, so that is a 0. Right, so now we're just going to simplify. So we have f of x is equal to 3 divided by 1. Right, so remember that in function notation, we let y is equal to f of x. So we have y is equal to 3 as our horizontal asymptote. So one thing to remember about the asymptote is that the answers must be written in the form of an equation. So just the key thing about the horizontal asymptote, once you divide by the variable of greatest degree, if your term doesn't reduce nicely to a number, then that term simply becomes a 0. All right, now we're going to find the vertical asymptote. Okay, so again, I'm just going to write the equation f of x is equal to 3x minus 4 over x plus 5. So if I go back to the cheat sheet, notice that there are no checkpoints. Right? It simply says completely factor the numerator and the denominator. Then set the denominator equal to 0 and solve. So taking a look at our problem, 3x minus 4 divided by x plus 5, we can't factor anything because it's completely factored. So from this point, I'm simply going to take the denominator, which is x plus 5. I'm going to set that equal to 0 and solve for x. So in order to solve for x, we're going to subtract 5 from both sides. So we have x equal to -5, which is the equation for the vertical asymptote. So lastly, we're asked for the slant asymptote. Right, so keep in mind we can't have a slant asymptote and a horizontal asymptote at the same time. So therefore, the slant asymptote does not exist. All right. Okay, so we're going to do another problem. Okay, and we're going to go through the exact same items. So we're given that f of x is equal to 2x squared minus 7x minus 15 divided by 3x squared minus 11x minus 4. Okay, and we're going to find the X-intercept or X-intercepts. Okay, because it's possible to have more than one X-intercept. So we're going to take the equation and set it equal to 0. So we have 2x squared minus 7x minus 15 over 3x squared minus 11x minus 4 is equal to 0. Right. So as we did in the previous problem, we're going to multiply both sides by the least common denominator, which is 3x squared minus 11x minus 4. So we multiply the left-hand side by the least common denominator. And we also multiply the right-hand side by the least common denominator. On the left-hand side, the 3x squared minus 11x minus 4 cancels. So we have 2x squared minus 7x minus 15 is equal to 0. All right, so we are looking at a quadratic equation. So the two methods we're going to use to solve the quadratic equation are either to factor and use that zero factor property, or we're going to use a quadratic formula. But here I believe this is factorable. So I'm going to make two sets of parentheses. So keep in mind, whatever we put in as our first terms, we must be able to multiply to get the first term in our trinomial, right? So we have 2x in x, right? Because the only way you can get a 2 is 1 times 2. Whatever we put as our last terms, we must be able to get the last term in our trinomial. So the only way I can get a 15 or a negative 15, here are my possibilities. I can have a negative 1 and a positive 15. I can have a positive 1 and a negative 15. I could also have a negative 3 and a positive 5, or a positive 3 and a negative 5. All right, those are all my possibilities. Okay. So I'm going to use a positive 3 and a negative 5. Okay. So now you can always get the first and always get the last, but the trick is the middle term. So you get the middle term by taking the outermost, right? So 2x times negative 5, that's negative 10x. And if I take the innermost, 3 times x is 3x. If I combine those, 3x minus 10x is negative 7x. Notice I get the correct middle term. So I know that this is the correct factorization. So now I'm going to use the zero factor property. I'm going to take every factor and set equal to 0. So I take 2x minus 3 equal to 0 and x minus 5 equal to 0. So in order to solve 2x plus 3 equal to 0, I'm going to subtract 3 from both sides and divide by 2. All right, so I have x is equal to negative 3/2. In order to solve x minus 5 equal to 0, I'm going to add 5 to both sides. So we have x equal to 5. So our two intercepts are negative 3/2 and 5. But if you write those out as ordered pair of points, we would have negative 3/2 comma 0 and 5 comma 0. All right, so those are the X intercepts. All right, so again, just take your equation, set equal to 0, and solve. All right, now we're going to find the Y-intercept. So in order to find the Y-intercept, we're going to let x equal to 0. So I'm just going to write out the equation again. So that's 2x squared minus 7x minus 15 over 3x squared minus 11x minus 4. All right, so 2x squared, I'm going to substitute x for 0, minus 7 times 0 minus 15, over 3 times x, which we're going to substitute for 0 squared, minus 11 times 0 minus 4. All right, so once we simplify the numerator, we have negative 15. Once we simplify the denominator, we have negative 4. In function notation, we let y equal to f of x, and a negative divided by a negative is a positive. So we have the y-intercept as 15 over 4. Or if you're asked to write it out as an ordered pair of point, we have 0, comma 15 over 4. All right, so here again, finding the X and the Y-intercept. Okay, so now we're going to look at the asymptotes. Okay, so next we're asked to find the horizontal asymptote. So I'm going to write out the equation again. All right, and we're going to take a look at the cheat sheet. So let's take a look at the bullet points. It says if the degree of the top is smaller than the degree of the bottom, then the horizontal asymptote is y equal to 0. Right, taking a look at our equation, notice that the degree for the top is 2. The degree for the bottom is 2. So that first checkpoint does not apply. And then the second one says if the degree of the top is bigger than the degree of the bottom, then no horizontal asymptote exists. So since the degrees are exactly the same, we're going to apply the bullet points and we're going to divide every term by the variable of greatest degree. So if we look at our variable, it's x. If we look at the largest power on x, it's x squared. So we're going to divide everything by x squared. So 2x squared divided by x squared, 7x divided by x squared, negative 15 divided by x squared. And we're going to do the same thing for the denominator. So once we divide everything by the variable of greatest degree, now we're going to reduce. So keep in mind, if it does not reduce to a number, right, it materializes to 0. So if we look in the numerator, 2x squared divided by x squared, the x squared cancels and we get 2 nicely, right? So that's a 2. 7x over x squared, that reduces to 0. Negative 15 over x squared, that also reduces to 0, right? Because it doesn't reduce nicely to a number. If we look in the denominator, 3x squared divided by x squared, the x squareds cancel. Okay, and that term reduces to 3. 11x over x squared, that reduces to 0. And negative 4 over x squared also reduces to 0. Right? So we have f of x, which we can write as y is equal to 2/3. And that is the equation for the horizontal asymptote. Okay. Next, we'll take a look at the vertical asymptote. So that's 2x squared minus 7x minus 15 over 3x squared minus 11x minus 4. Okay, so looking at the vertical asymptote, it says completely factor the numerator and the denominator. Okay, so let's do that first. All right, so we factored the numerator, right? We factored that out as 2x plus 3 times x minus 5. Next, we're going to factor the denominator. And I'll write that step over here. Factor the denominator. Three x squared minus 11x minus 4. All right, so here again, I'm going to make 2 parentheses. And whatever I put in as the first terms, they must multiply to give us a 3x squared. So the only way we can get a 3 is 3 times 1. So I'm going to put 3x in the first set and x in the second set. The next two numbers we place as our last terms. We must be able to multiply to get a negative 4. So the different possibilities to get a negative 4 are 1 times negative 4, negative 1 times 4, negative 2 times 2, and 2 times negative 2. Right, so we're going to use a plus 1 and a minus 4. So now notice I get my first term, 3x times x is 3x squared. I get my last terms, 1 times negative 4 is negative 4. But keep in mind the middle term is a combination of the outermost. So 3x times negative 4 is negative 12x. For the innermost terms, 1 times x is x, and if I combine those, I get negative 11x. So we can completely factor the denominator as 3x plus 1 times x minus 4. Now that we have the numerator and the denominator completely factored, what we want to do now is cancel any common terms if possible. Right, so notice I don't have any common terms, right? So I can't cancel anything. So going back to the cheat sheet, it says now we set the denominator equal to 0 and solve. So I'm going to take that denominator, which is 3x plus 1 times x minus 4. We're going to set that equal to 0. I'm going to use the 0 factor property. I'm going to set 3x plus 1 equal to 0 and x minus 4 equal to 0. And we're going to solve. So in order to solve 3x plus 1 equal to 0 for x, we're going to subtract 1 from both sides. Next, we're going to divide by 3. So we have x is equal to negative 1/3. In order to solve x minus 4 is equal to 0, we're going to add 4 to both sides. So we have 2 vertical asymptotes. X is equal to 1/3 and x is equal to 4. Okay. And then lastly, since we have A horizontal asymptote, the slant asymptote, does not exist. All right, and we're going to take a look at one more. So this is f of x is equal to 2x squared plus x minus 6 divided by x minus 2. All right, so we're going to run through the gambit for this equation. All right, so we're going to find the x-intercept. So we're going to set our equation equal to 0. And solve. So here again, we're going to multiply both sides by the least common denominator, which is x minus 2. So this reduces down to give us 2x squared plus x minus 6 is equal to 0. Now we're going to factor. So I'm going to put 2x and x in the front. And we're going to factor this as 2x minus 3 times x plus 2. So just to check that, notice that 2x times x is 2x squared. Negative 3 times 2 is negative 6. My outermost terms, 2x times 2 is 4x. My innermost terms, negative 3 times x is negative 3x. And if I combine my outermost and innermost terms, I get x. Right, so 2x minus 3 times x plus 2 is the correct factorization. So now we're going to set both factors equal to 0. And we're going to solve. So in the equation 2x minus 3 equal to 0, we're going to add 3 to both sides. Then we're going to divide by 2. In order to solve x plus 2 equals to 0 for x, we're going to subtract 2. So we have x is equal to 3/2 and negative 2. Okay, but if you had to write those as ordered pairs, we would have 3/2 comma 0 and negative 2 comma 0. So 2 X intercepts. And now we're going to find the Y-intercept. So we're going to let x equal to 0. So we have f of x is equal to 2 times 0 squared plus 0 minus 6. Okay, over 0 minus 2. So this reduces down to give us negative 6 over negative 2. So remember, function notation, we let y equal to f of x, so we have y equal to 3. Or if you're asked to write this as an ordered pair of point, we have 0, 3 as the y-intercept. All right, now we're going to find the horizontal asymptote. So I'm just going to rewrite the function. 2x squared plus x minus 6 over x minus 2. So if we look at our bullet points, and if we look at the last bullet point, it says if the degree of the top is bigger than the degree of the bottom, then no horizontal asymptote exists. So looking back at our function, the degree of the top is 2, the degree of the bottom is 1. So the horizontal asymptote does not exist. Right? So now we're going to find the vertical asymptote. So in order to find the vertical asymptote, it says completely factor the numerator and the denominator. So we've already factored the numerator as 2x minus 3 times x plus 2. And we have the denominator, which is already factored, as x minus 2. So we can't cancel any factors. So we're simply going to take the denominator, which is x minus 2. We're going to set it equal to 0 and solve. So if we add 2 to both sides, we have x is equal to 2, which is the vertical asymptote. So now we're going to find the slant asymptote. So let me just write out the equation once again. All right, so if we look at the checkpoint, it says if the degree of the numerator is 1 degree greater than the degree of the denominator, then a slant asymptote exists. Right, so we do have that condition. The degree of the top is 2, the degree of the bottom is 1. So in order to find that slant asymptote, it says we want to divide the numerator by the denominator and disregard any remainder. Right, so we're going to use synthetic division, okay, to do that. So for synthetic division, the first thing we're going to do is find a divisor. So I want to take my denominator, which is the divisor. We're going to set it equal to 0 and solve. Right, so if we add 2 to both sides, we have x is equal to 2. Okay, so keep in mind, everything is in descending order, right? The divisor is in descending order. We have the first degree term, which is x. We have the 0 degree term, which is 2. Our dividend is in descending order. We have the second degree term, the first degree term, and the 0 degree term. So we're going to set up synthetic division. So we have 2 as our divisor. And then we're going to list out the coefficients of the dividend. So that's 2, 1, and -6. Okay, that first number always comes down. So now we're just going to multiply and add. So 2 times 2 is 4. 1 plus 4 is 5. 2 times 5 is 10. -6 plus 10 is 4. So we have a remainder of 4. So remember that once we use synthetic division, we reduce the degree of our equation by 1. Right? So the 2 would be the coefficient for x, and 5 would be our constant. So notice that it says in order to find the, I'm just going to go back. It says to find the slant asymptote, we divide the numerator by the denominator and disregard any remainder. Right? So I'm simply writing out the slant asymptote is 2x plus 5, and we're going to disregard the remainder.